This is AP Chemistry Screencast 3.9. Types of redox reactions. Here's 6 types, and you can remember them just by the colloquial terms for each. If there's only one product, then that is a combination. For normal reactions, this was called synthesis. Here we'll simply call it combination. If it's falling apart from, say, one thing into two, that's a decomposition reaction. If oxygen is being used as a reactant and it's a redox reaction, meaning there are electrons being gained and lost, then this is a combustion reaction. If hydrogen is a product, then it is hydrogen displacement since it got displaced. If metal is a reactant, then it's metal displacement. And if halogens are a reactant, it is halogen displacement. Let's find the oxidation state of each atom or ion. For each reaction, let's do the reaction type, and let's answer the little question for each. Okay, aluminum plus bromine makes aluminum bromide. Sounds like a combination reaction. Aluminum is in a elemental form, and therefore the oxidation state is 0, as is bromine, even though it's bimolecular. And when it forms aluminum bromide, aluminum is going to be +3. Each bromine is going to be -1. That's right from the column that they're in, and that works. And therefore, the thing that got oxidized is the thing that lost electrons, and it's always the thing, therefore, that gets more positive. In this case, bromine's going from 0 to +3. For this combination reaction, aluminum got oxidized. Who did it? In other words, who took the electrons away? The oxidizing agent must be bromine, since bromine is going from 0 to -1. Did I have that right? Aluminum got oxidized. It goes from 0 to +3. It lost 3 negatively charged electrons. Bromine is going from 0 to -1, so it's getting reduced. That means it's an oxidizing agent. Okay. Potassium chlorate turns into potassium chlorine and oxygen. It appears to be falling apart. This looks like a decomposition reaction. Potassium is +1 always. The oxides are -2, giving us a charge of chlorine of +5 to offset that -6. Potassium chloride +1, -1. Oxygen molecular, so 0. What got reduced? If you're getting reduced, you get more negative. +5 to -1. That is a lot more negative. So chlorine got reduced for this decomposition reaction. The reducing agent must be oxygen, since oxygen got oxidized. It went from -2 to 0. That's more positive. That means it lost 2 negatively charged electrons. Sulfur plus oxygen combines to form sulfur dioxide. So this is an atom, not an ion. It's alone, so its oxidation state is 0. Oxygen is not an ionic form. It's alone, so even though there's 2 of them, that's oxidation state is 0. Sulfur dioxide, to offset the total -4 charge here, sulfur must be +4. And who got oxidized? Who got oxidized? Who got more positive? It appears that sulfur went from 0 to +4. So for this combustion reaction, notice that oxygen is a reactant. That's how we define combustion. The sulfur is oxidized by oxygen. Okay, strontium reacts with water to form strontium 2 hydroxide plus hydrogen. Strontium's alone, 0. Water, the hydrogens are +1, the oxygen is -2. Well, strontium I know must be +2 to offset the 2 negative hydroxides, but if we're breaking it down into elements, the strontium is +2, oxides are -2, hydrogen is +1, that works the same way. Hydrogen's alone, and it got displaced, by the way. That looks like hydrogen displacement. And so it goes to 0. The reducing agent must be strontium because it went from 0 to +2. A reducing agent gets oxidized, and that's getting more positive, and there you go. Titanium 4 chloride reacts with magnesium to form elemental titanium and magnesium chloride. Offsetting each -1 is titanium being +4. Reacting with elemental magnesium, therefore 0. Forming elemental titanium, therefore 0. The magnesium must be +2 to offset each of the -1s of chlorine. And Cl- goes from -1 to -1. It is not a reducing agent. It is not an oxidizing agent. It is simply a lurker. It's a spectator add for this metal displacement reaction. There it is. Metal displacement, titanium got displaced. What gets displaced here looks like a halogen, so we're going to have a halogen displacement reaction. Chlorine is in its elemental state, 0. To offset the +1s of potassium, bromine is -1. Potassium is +1 and -1. It looks like potassium did not change. Chlorine did get reduced. Bromine went from -1 to 0. It got oxidized. Nobody's asking. This is a halogen displacement reaction, and these are 6 types of redox reactions.